the statement we're trying to prove is that if n squared is even, that implies that n is even. And we're talking about the concepts of even and odd here, so let's assume that n is an integer for that to make sense. So the way we're going to do this is by using a proof by contrapositive. And that sounds complicated, but it's not too bad. What we do is write out a statement called the contrapositive, which is equivalent to this statement, but easier to prove. So the contrapositive here is if n is an odd integer, this implies that n squared is odd. And my claim here is that these two statements are equivalent, which I'm not really going to get into, but that is true. So essentially what we do is we negate both of these statements here and then sort of invert the statement. So hopefully you can see that we've changed n squared is even to odd and n even to n odd, which are the opposites. We've negated those statements and then we've flipped this implication round. So if we can prove that n being odd implies that n squared is odd, then we've proved that if n squared is even, then n is even. So we'll do that now. And we're going to do this by a direct proof. So if n is odd, then n can be written in the form 2k plus 1, where k is an integer. And expanding this out, expanding out n squared, which is 2k plus 1 squared, we get 4k squared plus 4k plus 1. We can take out factor of 2 from these first two terms, we get 2k squared plus 2k plus 1. 2k squared plus 2k is an integer. Therefore, this is odd. So we've now proved this statement, which in turn proves this one, and we are done.